We're going to be going over 2.2 or 1.2, which is the classification of matter. This is a really important lesson. Um, yeah. So first we have the state of matter. There's three for the most part. There's obviously other ones, but those are way too advanced for AP chemistry, and um, these are the ones we're going to be focusing on. So we have gas, solid liquid gas. Gas is no fixed shape or volume, but expands to fill its container, as we know. Um, if you put gas in a room, it's just gonna diffuse and it's gonna go wherever it wants. A liquid has a definite volume but no fixed shape. It takes the shape of its container. You put water in a water bottle, it's um, it's gonna become the shape of the water bottle. If you take that same water and put it in a big bucket, it's gonna be more spread out. It takes the shape of its container. Um, a solid has both a definite shape and volume. Like an ice cube, it's gonna have a definite shape and volume. You can change it if you press it hard enough, um, but that's what it is for the most part. Now, pure substances are matters with fixed composition and distinct properties, and we'll get into that right now. Um, take like a cup of water. Here's water. We probably should have drawn some waves on there. This is a pure substance. It's just water in itself. It's just H2O. All the molecules in here are H2O. But take that same water and add some salt to it. Salt is sodium chloride. Um, actually, there's other salts, but we'll be focusing on table salt here. You don't have to know this, but this is just a visual example. It's going to release other atoms into the mix. That is no longer a pure substance because it's no longer purely water. So that's really important to know pure substances. Um, I really want you guys to understand this because it's really easy to get chemistry when you understand what it really is instead of just memorizing the definitions. You have to apply it, and that's the most important part if you're going to be taking AP chemistry. And as you mentioned before, an element is just an identity. It's um, it's what an atom, um, the classification of an atom. So if an atom has one proton, it's the element hydrogen. Um, it's indivisible, as we know, so that's really important. We're gonna move on. But before we do, I do want to go over the structure of an atom. So first, sorry, I'm not a good drawer, so let me just try this. So this is the typical demonstration of an atom. As we know, mass is just energy, which we don't really have to focus on right now. But that's what scientists discovered. And this is not how an atom actually looks. There's no rings around it. But there is regions of electron density around, which we'll get to later. It's gonna be way later. But this is what an atom looks like. So first we have to understand there are two main components of an atom. There's the nucleus, and then we have all this outside stuff, which is just the electron cloud. And basically, the electron cloud contains obviously electrons. They're the only places electrons can be found. Well, you can find them in other places, but obviously for the sake of this demonstration, it's just going to be around these rings here. The nucleus is where the protons and neutrons are going to be found. And in chemistry, neutrons aren't really that important. It only, well, we have to know what it is, but we're not going to get into any nuanced things with neutrons, but we'll definitely get into electrons a lot and protons a lot. So the nucleus is the only thing that contributes to the mass. Technically, electrons do contribute to the mass, but they're so negligible that it doesn't count. And protons have a certain mass, and whatever the protons and neutrons add up to is the atomic mass. And this will be different for each element, but that's what the atomic mass means. And obviously, it's not going to be one. Like a proton doesn't weigh one. but they use relative scales, so they set whatever small weight. So if proton is 0.000000000001, whatever it is, they're just going to set that equal to 1 and set the neutrons relative to that. We don't have to worry about that right now. A the nucleus contains the protons and neutrons, and the electron cloud is going to contain the electrons. So this is what the basic structure of an atom is. But on a macroscopic scale, you can just think of them as little dots. This is an atom right here. And on the inside, it's going to be more complex. If we zoom in by like 1,000 times, right? So that's what it is. So an important thing to note is that an atom, a neutral atom, so just a regular atom, like hydrogen, um, is typically going to contain the same amount of protons as electrons. There are some exceptions, but we'll get to that later. But just know that an element will typically have the same number of protons and electrons in its most neutral, non-excited form. So, yeah, that's what it is. So a compound is a substance made up of two or more different elements chemically combined. A mixture is a combination of two or more substances where each retains its identity. So these sound similar. I mean, they're used interchangeably a lot by people who don't fully understand the definition. But I think the most important part to know here is that it's just the definition of a compound and a mixture. Um, so first, we have to understand that a compound is between just two atoms, and they change its structure to make a compound. Um, and the difference with a mixture is that a mixture um, typically uses electrostatic forces, um, because they're going to be positive and negatively charged atoms, which are called ions. Um, So one very famous one is sodium chloride, where sodium is a positive and chlorine is a negative, and the charges they come together and they basically satisfy each other's electrostatic field. So that's what it is. Um, a heterogeneous mixture is a mixture not uniform in composition or appearance. So take that's what a heterogeneous mixture is. If you put rocks in water, it's no longer going to be a uniform mixture because you can see the rocks. But a homogeneous mixture can be something like salt water, um, where all the salt particles are just all around the water and you can't really tell that this part is different from this part. So let's look at it from the top. Here is the container. It's kind of messy. Um, so this is all just salt water right here. If you can split it in half and one side looks different than the other side, it is not a homogeneous mixture. It's heterogeneous. And this will be really important for later. But yeah, it's at its crux, at its core, it's what it is. And a component is just a substance present in a mixture. It's one of the parts. That's what component is. So yeah. Take salt water. A component is salt. That's all it is. And that's going to be point C simplified. Thank you.